Hi, welcome back to Science 1206, the Chemical Reactions Unit. I'm Ms. Ledwell, and in this video, we'll talk about writing chemical equations. So let's begin. How to write a balanced chemical equation. Our first step is to write the unbalanced equation or skeleton equation when we are given a word equation or description of the reaction. Write the reactants on the left side of the arrow and the products on the right. Remember to look out for diatomic and polyatomic elements. Some helpful hints for determining the states of substances are our solids, represented by a lowercase s in brackets, may be referred to as a powder, precipitate, or metal. Gases, represented by a lowercase g in brackets, are commonly described as vapor. Aqueous solutions, represented by a lowercase aq in brackets, are typically labeled as a solution or noted to be dissolved. If the substance is an element at room temperature, you can find the state of matter on the periodic table. If insufficient information is given to determine the state, you may leave it out. Now we're going to do a little practice writing skeleton equations. So please pause this video, grab a pencil and some paper, and number your paper from 1 to 6. As each description or word equation in the table on the next slide is revealed, write down the skeleton equation. We will then review the correct answers one by one. Good luck, and after numbering your paper, please resume this instructional video. First, we have a description of a reaction. It says hydrogen gas and nitrogen monoxide gas react to form liquid water and nitrogen gas. Let's write the skeleton equation for this description. And the skeleton equation looks like this. So remember, for hydrogen gas, it's a diatomic molecule. So we need to have that subscript 2 attached to our hydrogen. And it told us in the description it was a gas. So next to it in brackets, I have a G, lowercase g in brackets. There are 2 reactants, so I have a plus sign to indicate that. My next reactant is nitrogen monoxide, and the formula for nitrogen monoxide is capital N, capital O, also a gas, which is indicated next to it. Then I have my arrow, and my products are on the other side of the arrow. There's 2 products, so they're separated by a plus sign. First, I have liquid water. Formula for water is H2O, and an L indicates that it's liquid. And nitrogen gas, again, it's a diatomic molecule, so I have the subscript 2 there and a G in brackets to indicate that it's a gas. The next one for you to try is another description. It says aqueous sodium hydroxide and carbon dioxide gas produces sodium carbonate solution and liquid water. If you need a moment between the description or word equation being revealed and the answer being revealed, be sure to pause the video. So for our answer for the skeleton equation, we have sodium hydroxide, which the formula is NaOH, and aqueous is represented by AQ in brackets next to that. There are 2 reactants, so I have a plus sign, and carbon dioxide gas, I have the formula for carbon dioxide, CO2, and gas indicated. Produces, I have my arrow and then my products. Sodium carbonate solution. Solution, remember, means aqueous. So I have Na2CO3, the formula for sodium carbonate, and aqueous next to that to tell us it's an aqueous solution, plus liquid water, H2O with L to represent liquid. Number 3 is also a description. It says magnesium metal reacts with sodium fluoride solution to yield solid magnesium fluoride and elemental sodium. What would your skeleton equation look like for this? So we have magnesium metal, that tells us it's a solid, which is indicated, plus sodium fluoride, the formula for that is NaF. It said it was a solution, which means aqueous, so that's indicated. To yield, that's our arrow, and then we have solid magnesium fluoride. MgF2 is the formula for that, and solid is there to indicate it's a solid, plus elemental sodium. Elemental sodium is a solid at room temperature, so that's indicated. Our next description says solid calcium carbonate combines with hydrochloric acid, HCl, to produce calcium chloride solution, liquid water, and carbon dioxide gas. So our skeleton equation looks like this. We have the formula for calcium carbonate there, CaCO3, and in brackets we have our S to indicate solid, plus hydrochloric acid, which is aqueous. And then we have our arrow and our products, our calcium chloride solution. We have aqueous there to indicate that, plus water, which is a liquid indicated, and carbon dioxide gas. Now we have a word equation. We have calcium carbonate breaks down into calcium oxide plus carbon dioxide. So our skeleton equation looks like this. It didn't give us enough information in the word equation for us to put in the states here, so I left those out. And for our last one, we have a word equation. Aluminum bromide powder plus chlorine gas produces aluminum chloride powder plus bromine liquid. Our skeleton equation looks like this. Notice that the solid is there because it told us it was a powder. Chlorine, it indicated a gas. Aluminum chloride, it told us it was a powder, so that's solid. And bromine was a liquid, so we've got that indicated. Also, chlorine and bromine are diatomic molecules, so we've got the subscript 2 there to indicate that. After you've written your skeleton equations, your next step is to count the atoms. You list each element underneath the corresponding side and count the number of atoms in the reactants and the products. The next step is to add the coefficients to balance the equation. Start with the elements appearing in only one reactant and one product. Use the coefficients to balance the number of atoms of this element on both sides. Remember, you can only change the coefficients, not the subscripts. Some useful guidelines are: remember, if the same polyatomic ion appears on both sides, treat it as a single unit and balance it as a whole. Balance hydrogen and oxygen last. These elements are often present in multiple reactants and products, so it's easier to balance them after the other elements are balanced. If an element appears with an odd number on one side and an even number on the other, start by multiplying the odd number by 2 to even it out. Then proceed with balancing the rest of the equation. Step 4 is to recount the atoms after each change and verify that you have a balanced equation. For example, in this equation, I'm going to recount the atoms and make sure it's balanced. On the reactant side, I have 4 hydrogen and 2 oxygen. On the product side, I have 4 hydrogen and 2 oxygen, so I check it is balanced. Now let's look at some examples. Our first example is, given the word equation, write a balanced equation. So our word equation is lithium plus water produces lithium hydroxide and hydrogen gas. Our first step is to write an unbalanced skeleton equation. Write the reactants on the left side of the arrow and the products on the right. Remember to look out for diatomic and polyatomic elements. So our skeleton equation looks like this. And I remembered that hydrogen was a diatomic molecule, so that's indicated there by adding the subscript 2. Next, we list each element underneath the corresponding side and count the number of atoms in the reactants and products. On our reactant side, we have 1 lithium, 2 hydrogen, and 1 oxygen. On our product side, we have 1 lithium, 3 hydrogen, and 1 oxygen. So this is not balanced. There are 2 hydrogen atoms on the reactant side, but 3 on the product side, so we must balance this equation. Next, we will add coefficients to balance the equation. We're going to add a 2 in front of lithium, a 2 in front of water, and a 2 in front of lithium hydroxide, and then we'll do a recheck. So once a change is made, we will recount the atoms and verify that we have a balanced equation. On our reactant side, we have 2 lithium, 4 hydrogen, and 2 oxygen. On our product side, we have 2 lithium, 4 hydrogen, and 2 oxygen. We have the same number of atoms on the reactant and product side here, so our equation is balanced. Now it's time to continue to the next video, where we will learn more about chemical reactions.